I will speak about practical experiences running Ceph in production. I want to say that it will be a very practical, very down-to-earth presentation. Don't expect something very technical, just I will explain how we use Ceph really in production. So I work at the University of Nantes. For non-French people, Nantes is a city in the west of France, in Brittany, or near Brittany. There is a lot of debates. Okay. We have only one university in Nantes. There is 21 faculties, institutes, and school of engineering in this university. And we have approximately 50,000 students and staff. My service is named IRTS, and it's managing infrastructure for the whole university, that is network, telephony, system services, and of course storage, and that's why we are here today. We will make a little focus on network topology because it's interesting for the rest of the presentation. We have 3 main points of presence. That is, our 21 schools and faculties are around these 3 points of presence. In each point of presence, we have a computer room with router, servers, firewall, etc. All these computer rooms are connected using dark fiber, and we operate these dark fibers at 10 gigabytes for the moment. And we will upgrade this to 40 gigabits before the end of the year. Sorry, something important. You can see we have very low round trip times between the 3 points. So even if there is more than 10 kilometers between our computer rooms, we are nearly in a local area network. We can consider that like an extended local area network. We also have 2 secondary points of presence in a city far, not near Nantes, approximately 80 kilometers from Nantes, and we operate it at 10 gigabytes also. But we have a much higher round trip time between the points. Okay. So now, is the time is working on? No, no. The time of the presentation. No, it's not working. Okay. 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 The state of the art in 2012. We have a lot of distributed services. We have 1 router per site, 2 firewalls, 2 load balancing in each computer room. So it permits a lot of high availability services, but in contrast, storage is still very centralized in 1 point of the university. It's a kind of historic, but it's really problematic because, of course, in case of accident, say a fire in computer room, we lose a lot of data. Even scarier, we lose also lots of backups. And of course, the whole university is down. So it's really something we don't want. It's very important to preserve data. So we were searching for something we can we search a mean to be very something which has the availability, high availability. Okay, so after a lot of try, we put Ceph in test, and we were really we see, yes, it was the thing. It was a huge potential. It has all the capabilities to meet our requirements. So we put it in production at the start of 2012. Okay, at this moment, we were before Argonaut release. There wasn't really guidelines, best practice. There wasn't best practice at this moment. So we tried with existing hardware, and of course we made some mistakes. So we started to use some blade servers, which only has 2 disks in it, and we put journals on it, and we use SAN storage, SAN arrays, using RAID 5. Okay, we were very naive, but you have to try. So in a few words, don't do that. It's not working very well. Starting with very young open source project is like playing Minesweeper. If you don't know where are the mines, if you're not able to read the indicators, in one word, if you don't know the rules, you're dead. So we try very hard to learn the rules of Ceph, but of course we have some problems. For example, like I said before, we were using pre-existing hardware, so we end up with few OSD with lot of data. It's not really great. We have also a big unique Ceph cluster, and as I said, we put journals on disk. It was really a bad idea. It was really not very well performing, and we also hit some bugs with kernel. Linux kernel, we have we made something a little bit. It was not a good idea. We put latest kernel on OSD, and we hit a virtual memory bug. The consequence was frequent crash of OSD. So as we have lots of crash of OSD, we have lots of rebuilds. And we also hit another bug with file systems. In the end, we have lose all OSD and all data. It was a test cluster, so it doesn't matter. Data is gone, okay, it's no problem. But you won't have to have this kind of failure in production environment. So we are thinking about it. How can we avoid this kind of problem? So there is a popular wisdom. We said, don't pull all your eggs in one basket. That's exactly what we have done. We have chosen to buy some dedicated hardware. So we have lots of more OSD and less data for each OSD. And we have made several totally independent clusters. It has lots of benefits. We can have administration independence. That is, we can have 2-3 people administering different clusters. Of course, we can have several Ceph versions and several distribution versions. And the real aim of this is to reduce risk in case of bugs. That is, we can have a Ceph cluster which has problem, but the other one is still running. It's important, in particular when you have production cluster and backup clusters. You don't want to have the two crashed in the same time. As we are a public university, we are quite tight on money. So we can't afford physical different clusters. Of course, we took the road of virtualization. Obvious route was KVM, that's why we choose LXC. No, there is really a reason to have chosen LXC because we want something which didn't put a big overhead on performances. In particular, in I/O performances, we need something that is very fast. LXC has much less overhead than KVM. That's why we choose that. Don't know how. Maybe a little bit faster. Okay. So our third deployment It's a current deployment. You can see we have 12 disks on this kind of server. Each disk is driven by an OSD, and each OSD is in one LXC. We don't need additional hardware ready. It's counterproductive. So each OSD drive a unique disk. We also have 2 shared SSD on this kind of servers to put journals. This gives us 12 OSD per machines and a total raw capacity of 48 terabytes. As we have 3 computer rooms, we made the same deployment in the 3 computer rooms. So we have a total of 540 terabytes in total in September. Okay, if we want to have really high availability, we also have to think in terms of networks. So, for example, take the Chantilly computer room. We have all our servers in this computer room. We have also MON and MDS on some LXC, but on non-specialized hardware. All our servers are using bonding, I mean LACP bonding with 2 interfaces. We have 10 GB public network and 10 GB cluster network. All of this is connected to the local router, and we use specific VLANs in each computer room. Why? Simply because our backbone networks can't use VRF, that is virtual routing, and when you have a router, it only can be in one computer room. Okay, so if all our OSD were using the same VLAN, in case of a problem in a data center, you lose the routing. Okay, so it's problematic. That's why we use specific VLANs on each computer room. So it's really a level 3 network, not switching, but routed. We have now 3 generations of hardware. They are more or less the same kind of hardware. The only difference is drive capacity and CPU power, and of course the price of the hardware is different. So we have right now a total of 15 servers deployed, and the next step is for October, and we will have 3 more servers. I said that we have 5 different clusters. We try to specialize these clusters. For example, we have the E cluster, which is only experimental. And in this cluster, we have the latest Ceph version. For example, the pre-Giant release will be tested in this cluster. And we have 2 production clusters, D, which is backups, which takes a lot of place. We have the latest stable long-term support version of Ceph there. We have the C cluster, which is the cluster when we run OpenStack and we have lots of different usage. We are replacing our SAN with this cluster. I will tell you more about this in the slide after that. And we also have 2 other clusters. The B cluster is for incubation, that is new projects. And in this cluster, we have the latest stable version, not necessarily a long-term support version. Long-term support is right now Firefly and Dumpling. For example, as far as I know, a giant won't be a long-term support. So in this one, in cluster B, we can put giant on it. And the A cluster is for third parties, that is research laboratory, like for example, genomics. There are teams in the university which produce lots of data with genomic sequencers, for example. And we will put data in this cluster. Just a little focus on different pools per cluster. Okay, so E cluster is experimental, so it's vary really often. D cluster have two pools for backups, Bacula in one hand, and Inifis gateway in the other hand, for all servers where you can't use Ceph because too old kernel, for example, or too old libraries. This is the way we can back up a lot of data on all servers. We just have a gateway which exports RBD volumes. We have 30, I see two more, yesterday we were at 36 USD. And lots of PG on this. The C cluster is for production, and we have a lot of things on that. We have mirrors, that is Red Hat, Ubuntu, Debian mirrors, for example. Right now we use replication for that, but soon I hope we will go to ERASURE coding pool to save space. We also have on-cloud instance with Samba in it also. So it's for our staff. We don't see much, but there is 3 replicates on it. And we're using RBD too. And we also have OpenStack pool, because we are not in production right now, but we will try to go in production next year. Okay. So to fulfill our high availability needs, how does it work? If you take the default crush rules, in general you have a rule who said Ceph choose leaf first end 0 types host. If you do that, you can end up with a copy in here and a copy in here, for example. Okay. So in case of the host is down, it's okay, it works. But in case of the data center is down, you have 2 copies in the same data center, so it's problematic. In fact, you just have to change the default rule, and you say choose leaf first type data center. Let's see how it works. For example, we take a pool with 2 copies. First step is you take data center Chantory and you choose the 1 leaf in this data center. So you have first primary copy is here, OSD 2, and you took another data center to put the second copy, choose Lombardy, and the data end in OSD 9. So obviously, if you lose Chantory data center, you still have a copy on another data center. The same is true for 3 copies. You have a total high availability model, like this. So how does it work in real life? It works well. We've really tested it. It's not a joke, huh? All of this really happened. Yeah, we have bad luck, I know, but it happens. So what we have observed is really it's very rare that a single OSD is down. What happens is a full data center is down. Okay, so it validates our choice. We really need to put data in data center and not on, you just have to choose data on different data center and not on different hosts. Okay, something to think about. When a client uses an OSD, a volume, an RBD volume, for example, he makes direct connections with all the USD. The more you have OSD, the more connection you have. If you have lots of OSD and lots of clients, you have lots of connections. You have to be very careful to not stressing firewalls. For example, I didn't say that, but we have lots of firewalls in all the paths. And some firewalls are sometimes not well tuned for this. There is some limits in the number of connections on simultaneous connections. So we already hit limits. So you have to raise the limits on firewalls and routers. Of course, the fact that a client made direct connection to USD is very good for scalability. And if you want good performance, it's great to have 10 gigabit on all the way. Another point, if you remember, we have 3 data centers, and we have servers spread in all the data centers. We also have clients in the same data centers. So we have something like locality of data. For example, this server is in the same data center that this OSD. Okay, there are 2 racks away. But data is spread all over our computer rooms. And right now there is no way to tell where is the best USD. For example, take this placement group, 3.C4. You have 2 copies. Primary copy is on OSD 11. Secondary copy is on OSD 8. Right now, you always take the primary copy. But bad luck, primary copy is away, is here, whereas secondary copy is here. It should have been better to take OSD 8. There is something in Giant that is coming that I think it's, I'm not sure, but I saw it in the blueprints. I'm not sure it's implemented in Giant, but there is something that is called a parallel read, I think, where you try all the OSD and the fastest OSD wins. Sorry, really my English is not so good, I'm sorry. In that case, it will be better, we will have a better latency in this case. We have other ways to reduce latency and reduce bandwidth also. We have a case where a science faculty, is connected at only 1 gigabit with us. Okay? So they want to use Ceph volumes to store home directories of students. Okay? When we tried, we totally saturate the 1 gigabit connection. And not only we had bad performance, but also a lot of people were crying, oh, no connection, nothing is working. Yes, the 1 gigabit was absolutely full. So you can do something. You can put an SSD locally on the server. On the client. It's a server also, but it's a client. This way, you cache a lot of data locally. And you reduce a lot the I/O. We tested it, it works very well. You can use bcache, dmcache, or NANTES. You have a lot of alternatives. Of course, it's only working with RBD with exclusive access.
How do you protect the data?
Depending if it's a write-through or write-back. Write-through is okay because data is written directly on OSD. With write-back, you take a risk, clearly. But you also improve the performance a lot.
But you take write-back.
No, we have write-through at this moment.
Okay, so you haven't installed the latency if you're using.
Sorry?
Oh, it's for read only?
No. It's a read-only, but not only read-only. In write-through, you write in the same time in the SSD and synchronously in the USD. So next time you read, you already have the data. So you reduce. But of course, all write-intensive workload put a stress on. Something we want to do in the near future is use tiering. I don't know how much time do I have?
3 minutes?
Sorry? Oh, okay. I've been too fast. Okay, so it's really something we want to do because we have 3 generations and yes, 3 generations of servers. So we can really have different class of services. Okay, we have slow but cheap storage and fast and maybe even faster in one month. So of course tiering is interesting because you put the data where it really needs to be. And we also want to test ERASURE coding because we have 3 main points in NANTES, but also 2 points in our university. Sorry. So it gives us 5 computer rooms. If we use ERASURE coding with only one OSD security, that is k equal 5 on m.
K equal to m1.
Yeah, that's it. We only have 25% overhead. So the cost of the usable terabyte is very low.
Oh, so that would be k equal 4, m equal 1 because you have 5 locations.
Yeah, that's it. Okay, so we have to test a lot of things because we don't know really if we can use La Roche-sur-Yon and Saint-Nazaire because there is really a big latency. I'm not sure performance will be sufficient. We really have to test that. Okay, we have some time, so we learned a lot in this process. You really have to put to avoid red, for example. It was in our minds. Sorry, difficult. In the first iteration, we still want red hardware because we are used to trust red, and it's not something in our minds to put data without red was risky. You have really to trust Ceph for that. But now we have understood that Ceph is stable enough and we can trust Ceph and we don't need red anymore. But if you want really safety, put a lot of the OSD. Don't put a lot of data on OSD. Just one disk, only one disk. You have also to choose a dedicated and fine-tuned hardware. Don't put data on how to say that. You just have to really fine-tune your hardware for Ceph. Okay. SSD for journals, yes, it gives a big performance boost, but beware, it's a very write-intensive behavior. Don't put MLC SSD because MLC SSD is not tailored for that. You better with SLC. We are wondering if we continue to use SSD or choose another way. For example, when you have servers with large number of disks, for example, you can choose in some hardware with, for example, 24 disk, but little disk. Maybe it's better to put the journal on this disk and don't put any SSD, because you have a lot of access. I think performance-wise, it's not really a problem. You take one OSD, it's one disk, and the journal is on the beginning of the disk because the faster cylinders are here. Listens to using LXC was really a good idea, really. But we choose maybe the way of putting one LXC per disk is maybe a bit overkill. Really, one LXC per cluster and per machine will be probably sufficient. But it looks flexible. Okay? And when you use LXC, you have to use a special network configuration. You can choose between MAC VLAN, Open vSwitch, or bridges. We want to go Open vSwitch because it's really great, but you can put IP table directly on it. And we are very paranoid about security, and we put firewalls everywhere. So for the moment, we're still using bridges, but it's not really good. It's add latency and it's not that fast. Well, Ceph can really push hardware to its limit, really. And you need a very reliable kernel. So choose LTS, long-term support kernel. I was discussing with someone at the lunch. We use now the 3.14 kernel, which is working quite well for us. But don't put the latest kernel, because you have the latest feature, but you also have the latest bugs.
Don't use the old one also.
Sorry?
Don't use two old kernels as well, because you have that
Yeah, aussi. Yeah.
It was a very nice one, actually.
Yeah. I have been hit by it.
Yeah, me too.
Yeah, okay.
Corruption.
Yeah, journal corruption?
Yeah.
Yeah, ouais, okay.
And then you think you have to run a check, but if you do that, then you actually corrupt the files.
Absolutely.
You should actually...
I didn't took much time to discuss the problem, but it was exactly that. We have two bugs, VM, virtual memory bugs, and also XFS bug. When the OSD were crashed, I mean 12 OSD crashed. When we started, only 9 of 12 started correctly, and 3 have corrupted file systems. And as we have only 2 replicates, we were dead. Okay, so be very conservative. If it's not broke, don't fix it. So really, don't change kernel version without God regions. Now it's really well known, but some time ago we were not really aware of problems with placement groups, and by default we have too much. We have too few PG per pool, and it's problematic because data is not really well distributed across different OSD. So you have to put much more PG to have an event placement of data. And you can also use tunable. For example, you can use optimal tunable that is better for data placement, but beware, you can have some side effects. For example, in Firefly, if you put optimal tunable, you turn on an option that is only compatible with latest kernels, and since maybe something you want to avoid. Of course, always keep enough space left to handle failures. In particular, when you lose a data center, you lose 1/3 of your data, and it's you have a rebuilding process, backfilling, and it can take a lot of place. So you have to have enough space left to handle that. Deploy Ceph with our own script, custom-made scripts. It's not really a good thing. We should go in the more mainstream, like Puppet, Ansible, Salt, etc. And we also lack some specific metrics on Ceph. We have metrics on hardware status, LXC status, CPU usage, disk usage, but we don't have specific metrics on Ceph. So we probably need something like Calamari or Inkscope, and of course better scripts. Just a little word on benchmarks. I don't know how. Well, yes. Don't trust benchmarks. If you benchmark Ceph, you may think, oh, it's not so fast. If you compare with SSD or SAN storage, for example. But a lot of benchmarks are mono-thread I/O. And the real benefit of Ceph is the parallelism of Ceph. If you put multi-thread I/O, you can see performance is really great. And the true benchmark is it works really well enough for our needs. But as anybody, no. It was with ON DUMPLING, so it's a bit old. Okay, so Ceph is the orange, you don't see, but the orange bar, and 100% is max elapsed time. So you see in some bench, Ceph is the slower of all. Sometimes really near other solutions. We have Ceph, 3 kind of SSD, local disk in SAS, and also SAN fiber channel in RAID 5 mode. So you can see in some tests it's slower, but sometimes it's really very fast. Don't know how next time is good. Okay, so Ceph is very stable. We use in production since 1 year and a half. It works very well for our needs, but you really need to know the best. That is, follow the mailing list, go on IRC, or if you don't have time, contract, because it's your data and you don't want to lose your data. A lot of more exciting stuff is coming. Stabilization of CFFS. Patrick said about this, performance improvement. So Giant is next big step, and it's quite exciting. Thanks, sorry for my English, but I hope you have questions.